Welcome to STG366, and thank you for being here. It's great to see a house full out here. I'm Hiren Chandiramani. I'm the go-to-market specialist for S3.
Hi everyone, I'm Huey from the S3 product management team. Is your guys' headphones working?
Okay.
Okay.
Cool,
Perfect.
thanks. We can't hear anything, so cool. So Matt Gorman, our CEO, in the keynote yesterday announced the preview of S3 Metadata. And we're really excited to talk to you about it. Hopefully you guys are to listen about it. So why don't we get started with that? Here's the agenda that we're going to talk through today. I will kick it off with a brief introduction of the data discovery problems that we hear from our customers. Really, it's in these conversations about these data discovery problems that really led to us implementing S3 Metadata. I'll then turn it over to Huey, who will go into the product details, how to get started, as well as a good chunk of the time will be spent on the demo, where he'll show you how to get started, a couple of use cases on that, and then I'll wrap it up with a quick recap. Okay? So with that, why don't we get into the data discovery conversations that we're having with our customers. We've been hearing from our customers that their data sets, particularly unstructured data in S3, have been growing at a tremendous rate. Currently, there's over 400 trillion objects in S3. That boggles my mind every time I think about it. That's a 4 followed by 11 zeros, and that number is growing every single day. And that data is from many different sources, for many different use cases and applications. You've heard the term data lakes thrown around. There are a lot of data lakes on S3. And the data that is coming in is multimodal. They have different kinds. You have images, you have audio files, you have videos, you have PowerPoints, you have PDFs, you have sensor data, financial records, medical images. All of that is being stored in S3 right now. And what we're hearing from our customers is that they have all this data and they would like to extract value from that. Right? There are many such use cases where they want to extract value, but the one that kind of stands out, most relevant today, so I'll use that as an example, is AI/ML training. A lot of our customers want to use this unstructured data that they currently have in S3 to train their AI/ML models, particularly Gen AI, right? So they are model builders. They have structured data, they have unstructured data. They want to use that to build their models, to train their models. On the other side, you have model consumers. These are customers who take these pre-trained models and then use the data they have in S3 to customize it for their own use case, right? And these customers have often millions, if not billions, of objects in their buckets on S3. And the challenge that they're facing today is that how do you find that right data set to train your models, as an example, right? How do you do it at scale, and how do you do it in a timely fashion, right? And so that's where metadata comes in. And we feel that metadata is key to helping solve that challenge. Metadata is data about your data. You guys all know this, right? But at the same time, if you add metadata to your object, it helps you find the right data sets. It helps you search for the right data sets. But your metadata is useful only if it's accurate. So you got to do that, number one. Number two, it's kept up to date. As an example, if your object is in one storage class, it moves to a different storage class. You want to make sure your metadata reflects that. If you're using object tags and you update the object tag, you want to make sure your metadata reflects that, mostly in real time, right? Not 24 hours later, but mostly in real time. And so today, what our customers are doing, they're taking a DIY approach. Many of them are building their own metadata stores outside of S3. Mostly, for example, maybe in DynamoDB, as an example. There are many different architectures out there. DynamoDB is one that's being used by some of our customers. They have to build their own code. Sometimes that's a Lambda function to extract that metadata, insert it into a DynamoDB table, and keep that updated in real time. As you can imagine, that's not easy to build. It's not easy to maintain. And especially when you're talking about the scale of thousands, hundreds of thousands, billions of objects in your bucket, doing that in real time at scale is a challenge, right? And that's exactly why we build S3 metadata. Yui?
All right. Thanks, Hiran. So we're now going to dive into sort of end-to-end how this feature will work. And as Hiran mentioned, our CEO Matt announced Metadata yesterday, which is a new S3 features that are currently in preview, but the idea is to help you accelerate data discovery, help you understand what you have on S3 using robust and rich object metadata. So we'll do a demo a little bit to make it a little bit more concrete, but there's a couple of things we want to highlight front and center. As Hiran mentioned, when we talk to a lot of customers, one of the problem they often cite is that as your data lake scale, sometimes it's hard to understand what you have and it's hard to find data. So the idea for S3 metadata really, if we boil down to it, is an easy button for you to click, and then we just start generating rich and robust object metadata, and S3 take care of all the heavy lifting for you. And so a few things we want to highlight. First is that as part of the preview, S3 metadata will automatically generate S3 system metadata, so things like storage classes, encryption type, size, but also more sort of advanced fields that today is a little bit hard to get, like object tags and what we call like user-defined metadata, which we're going to dive into that the specific fields in a bit. But these are metadata that you can use to annotate objects with metadata specific to your business context. The second thing we want to highlight is that as part of the launch, the metadata table will be stored in also the newly launched S3 tables, which was also announced by our CEO Matt yesterday. And what table does for you is that this is a new flavor of bucket type that inside of it, instead of storing objects like general purpose bucket today, is storing tables, and specifically iceberg tables. And behind the scene, these table buckets are specifically designed to improve query performance and improve TPS, and really designed for analytic workloads. And on top of that, these table buckets also take care of a lot of these. If you guys are, iceberg expert, you might know that if you manage the iceberg table yourself, you have to do compaction, you have to do orphan file removal today. So behind the scene, table buckets take care of that for you. So this is sort of the mechanism where we use to store the metadata table. And that means that by using S3 table to store the metadata table, we take advantage of a lot of these benefits of S3 tables, like more optimized for analytic workloads, less management overhead for you. This is weird. The last thing I want to mention is that the metadata is sort of generated near real time. What that means is that as data in your bucket changes, we will reflect that changes in the metadata table that we manage in near real time in sort of minutes level, so that you can easily query it as the data in your bucket changes. So here's sort of, to make it a little bit more concrete, here's sort of how it works. Let's say you have a bucket that you're ingesting a bunch of data, data of all kinds, CSV, images, video, audios. The first thing you do is to, if you haven't, create a table bucket. And this table bucket is where you will host the metadata table. The second thing you do is you configure this metadata as a bucket level property on the source bucket where you're hosting all these objects. And this is, we'll show a demo, but this is really easy to do. You can do either one single API call or a couple clicks in the AWS console. You basically just specify where's the table bucket to host the metadata table, and also how to name that table. Once that configuration is active, we'll just start producing this table and filling this table up with metadata as changes land in your bucket. So let's dive a little bit deeper into this output table, and there's a couple properties we wanna highlight. First is that as part of the preview, what this queryable table records is change events to your bucket. So specifically object creations, object deletions, and metadata update like tag update. And because this table records sort of changes to your bucket, we colloquially refer to this as like kind of a journal table because it's sort of it records the changes to your bucket. The second thing we want to highlight is that this table is a sort of a read-only table managed by AWS services, and only AWS services like S3 can modify it and mutate it and add roles. And what this means is that you kind of get something like a system table in the database world, where you have this sort of read-only authoritative ledger of changes that you refer to on what happened to your bucket. Now, even to be more specific, here's a list, as part of the preview, here's a list of metadata you will get in the output metadata table. As you might be able to tell, it includes sort of S3 system metadata like storage classes or size. It also includes, because it's recording change event, it also has sort of event-related metadata like when did this change happen, record timestamp, also the IP addresses that caused the change. And last but not least is the two fields we want to call out and that we'll dive a little bit deeper is object tags and also user metadata. And these are not generated by S3, but can be used by you to annotate an object with metadata specific to your business context. Once the table, the metadata table is in the table bucket, it needs to be easily consumable. Otherwise, it's not very useful. So the nice thing about using S3 tables to host this metadata table is that S3 tables already integrate with a wide range of AWS analytics tools today. That analytics integration part is in preview today. What that means is that you can, use Athena to query this table to understand, to do interactive queries to understand what data you have. You can use, let's say, QuickSight to build dashboards on how many deletes happen in the last, 7 days from this IP address. And table buckets also integrate with open source tools. And as part of release, we release a jar you can drop to your open source environments. And so what that means is that you can, if you don't like, use AWS Analytics Service to query this table, you can use open source Apache Spark to query this table. One more thing we want to call out is security. So security is super important to a lot of customers that we talked about. As part of the integration between S3 tables and AWS Analytics, it means you can take advantage of a lot of the nice thing that Lake Formation already built to enforce fine-grained access on S3 tables and S3 metadata tables. What that means is that you can use Lake Formation to enforce cellularized, so column and row level access to the metadata table. You can say like, oh, this group of user can only access these sets of metadata columns, and that set of user can only access the other set of metadata columns. And you can really be quite expressive with the permission you want to enforce here. So with that said, we'll do a demo of how, just show you guys sort of how this works end to end. And one thing to know is that we recorded this demo before, just so that we don't run into sort of technical issues here. And it might be hard to pause, so I'll try to talk fast to catch up with the demo. So let's see if, is this, okay. No. Nope. All right, let me see if there's, all right. So I'm in my S3. As part of the demo, I've set up a generous purpose bucket that's currently empty. And this is the bucket I'm interested in, generating metadata for. And right now it's empty. And as you can see, there's a new metadata tab on top now. And this is where I configure metadata as a bucket level property. And the configuration is fairly simple. You just specify the table bucket you want to put the metadata table and the table name. To show you guys the flow, we're going to show how to create a table bucket as well. So this is also pretty simple. You just click on the create table bucket, you name it. I name it metadata destination table bucket. And you also enable integration with AWS Analytics Services. And this is optional. I enabled it because I want to query this table from Athena later on. So this table bucket has been created. Now that I can go back to the source bucket I was showing earlier and configure the metadata and store the metadata table in that destination table bucket. Once again, very simple. I can see the table bucket I just created. And the table name, I'll just use whatever console gave me to do, but I can modify it. It's a modifiable text box. One click, and the metadata configuration is now active. What that means is that any new changes to the bucket is now being recorded and being sent to this destination table bucket. And to generate some load, we just wrote this pretty simple Python script that will generate sort of fake TXT objects and upload it to S3. And you might saw that, but it also includes some sort of tags and user metadata that we'll use to annotate object with things that I care about, like team, department, what compliance they use. So I'll run the Python script. I'll run it a couple times just so that it generates a slightly higher load on the bucket to simulate, I guess, more real world workloads. These objects are being uploaded right now. And what this means is that S3 metadata are recording the changes and sending that to the destination table. The next thing I do before I can query it is to grant lake formation permissions to this table because I want to query this table from Athena. Now, once again, because lake formation has this fine-grained access, you can use this to grant cellularized column and row level access to end user. But for here, I'm just going to grant it access to the entire table, and I'm going to use. I'll show this in a bit, but as you can see, here's the schema of this table. These are the 21 fields we showed earlier. And from lake formation, I'll do a grant permissions, and I'm going to grant it to the admin role, which I am going to use to query this table from Athena. But once again, this can be changed to whatever you like, depending on your situation. And I'm just going to do grant select describe on the entire table. If you want to do cellularized access control, you can do that as well. So once the data permission is in place, I can now go to Athena and query this table. The first query I would just do is a simple select star from this table. And we'll do limit 10 just to show that this table exists and the rough schema of that table. So if I click running, it will show me this table now. And once again, it has all these 21 columns I would describe earlier about objects in the bucket. And it has these custom metadata, which we'll dive into later. So to make it a little bit more real, we hear a lot of customer telling us, one common use case is that I have a lot of business unit that's uploading to this bucket that I manage for the company, and I want to be able to do cost attribution. It's like which business unit is sending how many requests, and how can I cost attribute very effectively? With metadata table, this can be quite simplified to a simple queries where, here we're just showing different departments using custom metadata that annotate objects to know cost attribute and understand how many teams, which team is generating how many requests on the bucket. So that's a simple demo just to show you you guys sort of an end-to-end workflow of how to set this up and query it from Athena. But once again, a lot of these can be tailored to your specific business context, the query engine, the access controls, what kind of objects are ingested, and our customers are very excited about metadata. And for just an example, SmugMug, which is a leading image hosting sites and one of the first adopters of S3, they store hundreds and billions of objects and images on S3. And S3 metadata, what they allow SmugMug to do is to easily explore their large amount of data easily and affordably. So now we want to talk about a little bit more advanced part of S3 metadata. And the first thing we want to talk about is custom metadata. And we mentioned previously there are two fields in the output table, object tags and user-defined metadata. What are they? So object tags are these mutable object level tags you can attach to objects, and you can change it whenever you like, even after the object has been created, and with arbitrary key value pairs. User-defined metadata are these immutable metadata that you attach as part of extra headers when you upload an object to S3. So these two metadata are not generated by S3, but you can use it to define metadata specific to your business context. So things like which department owns these objects, whether this object has sensitive information or not. So you can use these metadata to sort of annotate object with metadata specific to your business context. And once these metadata is there, we will tabulate that in this table so that it's easily queryable. Another pattern that we would expect customer to join or use custom metadata is your own table. So this is the most flexible way to generate metadata. And because the S3 metadata table is in the table bucket that can host other table as well, what this means is that you can create another table. You can set up your own architectures to extract whatever metadata that you would like. Let's say evoking Bedrock to generate a summary of PDF documents. And whenever you want, joining these sets of custom generated metadata and the S3 generated metadata is just a SQL join away. So as a concrete application of the custom metadata, and this is something that our CEO Matt didn't talk about yesterday, is this new integration with Bedrock. So with generative AI, we're seeing an explosion of synthetic and AI-generated data. And we're hearing customers telling us that in this world of synthetic data, I want to be able to tell very quickly what is AI-generated data and what is not AI-generated data, so that I might kick off different compliance internal requirements to review these piece of contents. Additionally, customers are telling us that I want to track lineage of how a piece of metadata, how a piece of AI-generated data was generated. Which model, what time was it generated? So as part of the Nova model launch yesterday, Bedrock will begin annotating video and images that are outputted and stored on S3. And specifically using the immutable user-defined metadata we just talked about. And specifically, Bedrock will annotate a few things, like this object is generated by Bedrock, which model generated this piece of data, which request ID, invocation ID sent to Bedrock generated this metadata. What this means is that because S3 metadata now tabulate all these user-defined metadata in a table that's easily queryable, you can use this to very easily understand what is AI-generated versus not AI-generated data, and also be able to understand lineage. So for this group of videos and images that were generated by Bedrock, how exactly were they generated, when, and what is the invocation ID that generated them? So we'll show you guys another demo that's a little bit more show the custom metadata piece. And once again, custom metadata is very important to our customers. And we talk to a lot of customers who come from all kinds of verticals. You might be working in media entertainment. Some of you might working healthcare, and you're ingesting all kinds of different types of data, and you care about different types of metadata. So as part of the launch, we put together a sample implementation with sample code that we'll publish in the next week or so, that give you a blueprint of leveraging S3 metadata and S3 tables together to have that pattern, the third pattern that we talked about, where you have your own pipeline and generating metadata that you care about, and use that in combination with the S3 metadata tables. And to give you a sneak peek, here's sort of what the sample implementation includes. It focuses on images and with sort of media entertainment use cases in mind. but you can easily switch that to other file types like genomic files or medical images that are meaningful to you. And this implementation consists of two modules. One is running a Lambda function that respond to S3 events and extract metadata about the content of the images being uploaded. And there are two types of metadata that are being extracted. The first is sort of technical image metadata, things like image resolution, width, and height. And the second is that we're going to call recognitions to run some ML on images and detect entities and detect labels within the images. So if there's a baby, you can tell there's a baby. If there's elephant, it will tell there's elephant. And once the metadata has been extracted by this Lambda, we'll use a Flink applications hosted by managed service for Flink to write the metadata to Iceberg table hosted in the table bucket. And once this is in a table bucket, you can join that with S3 metadata. So we'll run a demo of how this is set up. So once again, this will be available for you guys to download and modify as you like in the next week or so. So we built this sample implementation as a CDK. So the first thing we do is just to build a CDK and deploy the CDK to our account. And what the CDK does is that it creates a few things. It creates an input table bucket. It creates an input bucket that I will upload images. It will create a table bucket as output to store the metadata table. But these are, once again, customizable. So if you guys want to point it to a table bucket you already created or a bucket that you already have to host images, you can do that as well. So just let it deploy for a bit. Now that the CDK has been deployed, what I will do is to go into the empty bucket that it created for me and to enable S3 metadata. And this is once again follow the flow that we showed before, where you just specify the destination table bucket and you specify how do you like to name the metadata table. And once that has been configured, as images are uploaded to this bucket, we'll just start recording change events and start putting that into this destination output read-only table in the table bucket. So to prepare for this demo, we also prepared a set of images just to show you guys like what they would kind of look like. And we will now run a script to upload these images to the bucket we just saw that we have metadata enabled. And what this will do is that you see that images are now being uploaded. Behind the scene now is doing a few things. One is that S3 metadata will see these change events and record the S3 system metadata and put that into the metadata table. The other part of the implementation where S3 events, Lambda, and Flink are also now running, it will extract these sort of technical image metadata like heights and width, and also running recognition to detect label within the images and store that in a vanilla or regular table in the table bucket. So more images are being uploaded. And once again, these code will be available for you guys to modify in the next week or so. So while those images are uploading, I'll just go to my bucket that's hosting these images just to check. We see that these images are here. What I can now do is go back to Athena to query these tables and join these two tables together. The first thing I will check is that is the S3 metadata table. So if I choose those, just to verify that these tables exist, I can see that the metadata table exists and it contains the sort of 21 fields that we talked about earlier. I will now query the other table, the self-managed, so to speak, table in the table bucket. And this one will have the Lambda extracted metadata inside of it. And to show the schema, here's roughly what it looked like at bucket key version ID, but also things like image height and width, and this column called metadata, which is just a JSON dump of all these technical metadata that we extracted, but also labels here, which is what we run recognitions on to detect what's inside of the images. If we run a concrete example, let's say you have millions of images and you want to identify images that were part of the project Africa, and it contains elephant in it, and sort of what kind of storage classes these images belong to. These are, can be simplified to a single query. If I want to run another query that identify how are images that contain soccer ball being uploaded or being done in the bucket, I can do that as well. So here I see a list of events that happen to images that contain soccer ball. So some creations, different images, and some deletions, and some updating metadata. But these are just a very simple example to show you guys how you can use this reference implementations. But once again, code will be available for you guys to modify, and you can modify it to your specific business use case. Last thing I will say is some of our customers like Roche, which is planning to use S3 metadata exactly in this sort of custom metadata pattern that we just described, where their use case is that as they are building more and more LM applications like internal bot for sales team, their volume of unstructured data is growing, like PDFs and company documents, and they care about the S3 system metadata, but they also want to care about business context specific metadata, like they want to classify this document into different departments. And so what they will do is they will use the S3 metadata as a sort of index source of truth of what's inside of their bucket, and run their own Lambda to extract metadata specific to their business context.
Cool. Thank you, Yui. All right, so we're going to wrap up real quick. We showed this slide before. I'm going to show it again to wrap it up. So S3 metadata, the key value prop here is the simple, easy, automatic extraction of metadata, whether that's system metadata or custom metadata from your objects in S3, right? And when you talk about custom metadata, it's both object tags, which are mutable, as well as user-defined metadata, which are immutable. And we extract them, and we utilize the S3 tables that we just announced, AWS managed S3 tables that takes care of all the compaction, snapshot management, etc. So all the metadata is stored in those S3 tables, which makes it very easy for you to query it. You can also use this to join it with another table where you could generate metadata from recognition, as Huey showed you. And we feel that this feature has been very compelling, or will be very compelling, for anybody who has a lot of objects. You want to identify data sets, or you want to identify changes, right? For example, who uploaded data? What objects were deleted in the last 7 days? How many objects are in a particular storage class? Things like that, right? Will be very useful you will be able to do that very easily and very simply using S3 metadata. There are some additional resources that we like to point you to. Jeff Barr wrote a blog that talks about the feature, how to get started, but also there are some more example use cases in there with some SQL queries to get you started. There's a full documentation. Even though there's a preview, there's a full documentation out there to help you. We will be also publishing a Getting Started blog in the next couple of days, maybe next week, which will go step by step on everything that Huey showed you, as well as how Huey mentioned, the second demo he showed you. That will also be published relatively soon. Finally, I know everybody asks about pricing, and we didn't touch on that, right? I can see some shaking heads out here, right? So this feature will be priced per mutation. Like you said, every time there's a change in the object, either a put, delete, update of object tags, or even a change of storage class, there's a new line or a mutation in the S3 table, right? Metadata table. So we're going to charge you per million mutations or updates to the table. I've put a link to the pricing page. You can go there. It's live right now. So if you can go to the S3 pricing page, you can see the pricing per million mutations for the region that you're interested in. Okay. With that, thank you for coming here. We can't take any live questions here, but Huey and me will stand outside. We have time. If you have any questions, come see us. We'll be happy to answer those. Thank you.